Pyramids and cones have a base just like prisms and cylinders. The difference is, in a pyramid and a cone, that base is not the same all the way through to the top. Instead, that base tapers down to a point called the vertex. If I want to find the lateral area and surface area of a pyramid and a cone, I want to first look at a net of a pyramid. A net will help me better understand what is making up the lateral area and the surface area. So this is a net of a hexagonal pyramid. I have a hexagonal base and all the sides fold up to make a pyramid. So if I want to find the lateral area is going to be made up of all of these triangles. The lateral area will be the area of these triangles added together. To find the area of one of these triangles, I need to know the length of its base and the height of that triangle. And if I know the base and I know the height of that triangle, to find the area, I'm going to use 1/2 times base times height. Now I want to point out a few things. This height is the altitude of my triangle. It meets the midpoint of the side of my base. If you look at all of these triangles together, if I add up all of these bases together, I have found the perimeter of my base. So I'm going to use that perimeter in the formula for the lateral area of my pyramid. If I look at this height, when I fold these pieces up to make a pyramid, this height will actually be on the pyramid. The height that was on the triangle when folded up becomes this height. Now it's not the height of my pyramid, it's actually my slant height, which I'm going to abbreviate with a italics L. This slant height is on the face of each side of my pyramid. On a cone, that slant height will be on the surface of the cone. Notice again that this slant height hits the midpoint of my base. Now this is the part where you have to use a little bit of your imagination. Inside of this triangle, or inside of this pyramid, is a triangle. If I connect my slant height with my height of my pyramid, and I connect those two lengths together, I've created a triangle inside of my pyramid. If I do the same thing here, if I connect the height of my cone to the slant height and connect those two lengths together, I've created a triangle inside of my cone. I'm going to call that triangle the slice triangle. The reason I call it a slice triangle, if I sliced this pyramid, the face that I would create would be this right triangle. I'm going to look at this slice triangle in 3 dimensions. I have 2 pyramids. On the surface of each pyramid is my slant height. The height of my pyramid will be this length. And if you look, when I connect the slant height to the height, I've actually created the apothem of my base. If you look, this length right here is the apothem. I've connected from the center of my base to the midpoint of one of my sides of my base. So my sliced triangle has three sides. One leg will be the height of my pyramid. One leg will be the apothem, and the hypotenuse will be the slant height. So my sliced triangle is always going to be a right triangle. One of the legs of my sliced triangle will be the height of my pyramid or my cone. The other leg will be my apothem, connecting from the center of my base to the midpoint of one of the sides. In a circle, that apothem will be the radius of the circle. And the hypotenuse of my sliced triangle will be my slant height. So let's use that information to develop a formula for the lateral area of a pyramid and a cone. If you remember, the lateral area is the area of all of these triangles. So I want to use the area of a triangle formula. The area of a triangle is 1/2 times base times height. Well, the base of all of these triangles will make up the perimeter of my base. So I want to use the perimeter of my base in my lateral area formula. And the height of each of these triangles will not be the height of my pyramid, but rather the slant height in my pyramid. So the formula is going to be 1/2 times the perimeter of my base times the slant height. Now, from my lateral area to figure out my surface area, I want all of these triangles, the area of all of these triangles, and the area of my base. So I want my lateral area and one bottom. Different than a prism or a cylinder, I don't have a top and a bottom, I just have a bottom. So the two formulas that I need to learn for pyramids and cones, 1/2 times my perimeter times my slant height for the lateral area, and my lateral area plus one bottom, one base for my surface area. Let's do example number 1. First thing that I always want to do is draw out my base. In this case, I have a cone. So my base is going to be a circle. And I'm told that my radius is going to be 4. Now I want to find the perimeter and the base area. The perimeter is going to be 2 times pi times my radius, which is going to be 8 pi. And my area is going to be pi times r squared, 16 pi. Next thing that I want to do, I want to draw out my slice triangle. My slice triangle is always going to be a right triangle, and it's going to be made up of 3 parts. The height of my pyramid or cone, the slant height, which is the length on the face of my pyramid or cone, and the apothem. So my slice triangle is this length, and this length. In my example, the height of my cone is 8. So I need to figure out my slant height. To do that, I'm going to use the Pythagorean theorem. 64 plus 16 equals L squared. 64 and 16 is 80. Take the square root. L is going to equal the square root of 80. Well, I know that 80 can be divided by a perfect square. In fact, 80 can be divided by 16. 16 times 5 is 80, so the square root of 80 simplifies down to 4 square roots of 5. So my slant height is 4 square roots of 5. To figure out my lateral area, 1/2 times my perimeter times my slant height. So I have 1/2 times the perimeter of my base I figured out to be 8 pi times my slant height, 4 square roots of 5. Well, 1/2 and 8 can be simplified down to 4. So I really have 4 times 4, which is 16, times pi times the square root of 5. Now that's as far as I can simplify down. 16 pi square roots of 5 is my exact answer. And I'm finding the lateral area, so I'm going to measure it in units squared. To find my surface area, I'm going to take my lateral area and add in 1 base area, 1 bottom. So I'm going to take 16 pi square roots of 5 and add in 16 pi. Now here, both of these are unlike terms. They both have a 16 pi in them, but here I have pi square roots of 5, and here I just have pi. If I had a problem that looked like this, 16xy plus 16x, xy and x are unlike terms. I can't add these two terms together. So when I have 16 pi square roots of 5 and 16 pi, these are unlike terms. This is as far as I can simplify. So my surface area is 16 pi square roots of 5 plus 16 pi. Example number 2. Again, first thing that I want to do, draw out my base, find its perimeter, find its area. In this case, my perimeter is going to be a pentagon. And I'm told that I have a base side length of 6. So this side length from here to here is 6. So to find my perimeter, I'm just going to take 6 times 5 and get 30. My base is a regular polygon. In this case, a regular pentagon. So to find the base area, I want to use the formula for a regular polygon. 1/2 times the perimeter times the apothem. Well, I just figured out the perimeter. I need to figure out my apothem. To do that, I need to do some problem solving. I'm going to make my apothem a part of a triangle. And that triangle is going to be a right triangle made up of the apothem and this length and this hypotenuse. Well, this length is going to be half of my side length, 3. And my apothem I'm going to figure out using, well, in order to do that, I need to figure out this angle. So I'm going to figure out this angle. The angle of a regular polygon is the number of sides minus 2 times 180. That's how many degrees I have total in this pentagon, divided by the number of sides. So each angle in a pentagon is 108 degrees, which means that this angle right here is 54 degrees. To figure out my apothem, since this is 54 degrees, I can't use my special right triangle rules. I have to use trig. In this case, I want to use tangent. So to figure out my apothem, I'm going to use the tangent of 54 degrees equals the side opposite my angle, A, over the side adjacent to my angle, 3. Cross multiply, I end up with A equals 3 times the tangent of 54 degrees. So my apothem is going to be approximately 4.1. I'm just going to round to 1 decimal place. So my base area is going to be 1/2 times 30 times 4.1. Since I have a decimal, I can include a decimal in my answer. I don't need to find my exact answer. 1/2 times 30 times 4.1. So my base area is approximately 61.5. Now I need to move to my slice triangle. My slice triangle is going to be a right triangle, and it's going to be made up of 3 parts. The first part is going to be the height of my pyramid. The second leg is going to be my apothem. So I'm going to go to the midpoint of one of my sides. And the third part is going to be my slant height. In this case, my slant height is given to me, 5. My apothem I just figured out, 4.1. And the height of my triangle, I need to figure out using the Pythagorean theorem. My height squared plus 4.1 squared equals 5 squared. I'm going to use my calculator to figure that out. 5 squared minus 4.1 squared. Take the square root of that answer. So my height of my pyramid is going to be about 2.9. So let's figure out my lateral area and then my surface area. Lateral area is 1/2 times the perimeter of my base times the slant height. So I have 1/2 times 30 times 5. 1/2 times 30 times 5 is 75. So my lateral area is 75 units squared. And my surface area is going to be my lateral area plus 1 bottom. So it's going to be 75 plus 61.5. 75 and 61.5 is 136.5. So my surface area is 136.5 units squared.